Next problem. The cross power spectrum of real random process x of t and y of t is given by s x y of omega is equal to a plus I b omega mod omega less than 1, 0 otherwise. Find the cross correlation function. So we'll see the solution. Given s x y of omega which is equal to a plus I b omega mod omega less than 1, that means minus 1 omega less than 1, 0 otherwise. That is equation number 1. The cross correlation of x of t and y of t is given by r xy of tau which is equal to 1 by 2 pi integral minus infinite to plus infinite s xy of d omega. We know r is equal to m of s. That is what. So 1 by 2 pi we are applying 1 here. Integral minus 1 to plus 1 a plus I e power I omega tau d omega. Right. In 1 they have given the limit is minus 1 to plus 1. Omega lies between and s omega. So 1 by 2 pi integral minus 1 to plus 1 a into e power I omega tau d omega plus 1 by 2 pi I b omega e power I omega tau d tau. So taking a outside the integral a by 2 pi omega tau d tau. There IB is constant, we are taking it outside from the integral IB by 2 pi integral minus 1 to plus 1 omega e power I omega tau d omega is equal to a by 2 pi integral minus 1 to 1 IB by 2 pi integral minus 1 to plus 1 omega. We are taking e power I omega tau as derivative of e power I omega tau by I tau. We know derivative of e power ax is equal to a into e power ax. So we need only e power I omega tau. That is why we divided e power I omega tau by I tau. Right. Now we are integrating a by 2 pi e power ax integral e power ax is equal to e power ax by a. So e power I omega tau by I omega tau. So lower limit minus 1, upper limit plus 1 plus IB 2 pi. We are using integration by part here. Or you can use Bernoulli's formula. So integration by parts are UV formula, same, right? So that is integral u dv which is equal to uv minus integral v du. Here u is equal to omega and v is equal to e power I omega tau by I tau. So applying that one, uv w into omega into e power I omega tau by I tau, lower limit minus 1, upper limit plus 1. Minus integral v du, integral minus 1 to plus 1 v e power I omega tau by I tau into derivative of omega, right, du. So applying upper and lower limits, a by 2 pi e power I, instead of omega we are putting 1, so I tau by I tau minus e power minus 1 minus I tau by I tau plus IB by 2 pi. Applying upper limit and lower limit, so instead of omega you are putting 1 into e power I 1 into tau, so e power I tau by I tau minus 1 into e power minus I tau by I tau, that is minus next term 1 by I tau. We are taking the term outside the integral. So integral minus 1 to plus 1 e power I omega tau d omega. So a by tau pi e power I tau minus e power minus I tau by 2i. Right. We are bringing the 2 here and taking the tau outside the bracket. Plus IB by 2 pi 2 by tau I. Right. Because we are multiplying 2 in the numerator and in the denominator. So no need, we can take it that 2 inside. No, okay, no problem. 2 by tau I e power I tau I minus into minus plus e power minus I tau by 2 minus 1 by I tau integrating e power I omega tau by I tau, lower limit minus 1, upper limit plus 1, a by tau omega tau pi. So that formula is sin tau. Sin tau we know is equal to e power I tau minus e power minus I tau by 2i. Sin in terms of exponential function plus IB by 2 pi. This is cos in terms of exponential, cos tau is equal to e power I tau plus e power minus I tau by 2 minus we are applying the upper limit again e power I tau by I tau minus lower limit e power minus I tau by I tau square, because I tau into I tau in the denominator, so I tau square. So that is equal to a by tau pi sin tau plus 2I pi by 2I tau pi cos tau minus I b by 2 pi e power I tau plus e power minus I tau by I square minus 1, so minus tau square. So that is equal to a by tau pi sin tau, and so 2I cancel, so b by tau pi cos tau I square b e power I tau minus I e power minus I tau by I 2 tau square pi, right? So a by tau pi sin tau plus b by tau pi cos tau minus b by tau square pi I square minus 1. So the bringing that 2I to the denominator of e powers. So e power I tau by e power I tau minus e power minus I tau by 2I. So we can use the formula sin tau. So a by tau pi sin tau plus b by tau pi cos tau minus b by tau square pi sin tau. So 1 by tau pi is common, so take it outside. A sin tau plus b cos tau minus b by tau sin tau. Next problem. The autocorrelation function of the random process x of t is given by r of tau, which is equal to 1 minus modulus tau by t. Mod tau less than or equal to t, 0, mod tau greater than t. Find the power spectrum of the process. Given r of tau is equal to 1 minus modulus tau by tau, so tau lies between minus t2 plus t, 0 otherwise. That is equation number 1. We know power spectrum is s omega, which is equal to inverse Fourier transform of r minus infinite to plus infinite r tau e power minus omega tau d tau is equal to minus t2 plus t, applying 1 here, 1 minus modulus tau by t e power I omega tau d tau, right? So that is equal to minus t2 plus t, 1 minus mod tau by t cos omega tau minus I sin omega tau d tau, because e power minus I omega tau, which is equal to cos minus I sin, which is equal to minus t2 plus t, 1 minus mod tau by t cos omega tau d tau minus I integral minus t2 plus t I 1 minus mod tau by t sin omega tau d tau. In the end, first integrand is an even function, because 1 minus mod tau by t, mod tau always positive, right? And cos is positive, sorry, even function. So both are even. The second integrand 1 minus mod tau by t is even function, and sine is odd function. Even into odd you will get odd function, so second integrand is in odd function. So we are using the properties of definite integral. So first one, if for the even function, it will become 2 times 0 to t 1 minus mod tau by t into cos omega tau d tau. Second integrand for the even odd function, the integral value is 0, so we are taking 0 as it is, which is equal to 2 integral 0 to t 1 minus tau, because in the positive sector 0 to t, capital T, positive limit, mod tau become tau by capital T cos omega tau d tau, which is equal to 2 integral 0 to t 1 minus tau by t derivative of sin omega tau by omega. So we are integrating using uv formula. Integral u dv is equal to uv minus integral v du. U is equal to 1 minus tau by t, and v is equal to sin omega tau by omega, 2 into 1 minus uv tau by t into sin omega tau by omega 0 to t minus integral v du 0 to t sin omega tau by omega derivative of 1 minus tau by t is equal to in 1 minus, so giving upper limit, instead of tau we are replacing capital T, t by t sin omega t by omega minus lower limit 1 0 0 1 minus 0 sin 0 minus integral 0 to t sin omega t omega tau by omega minus dt by d tau by t, which is equal to 2 into, so first term is also 0, t by t 1 minus 1 0 sin 0 0 second term, so that overall 0, 0 plus 1 by omega t, 0 to t sin omega tau d tau is equal to 2 by omega t sin omega tau integration minus cos omega tau by omega lower limit 0 upper limit t. So 2 by omega taking the omega outside, so omega into omega square into capital T minus cos omega t upper limit minus of cos 0 lower limit, cos 0 1, so minus into minus plus 2 by omega square t 1 minus cos omega t. We know 1 minus cos 2a which is equal to 2 sin square a. A otherwise you can take 1 minus cos a is equal to 2 sin square a by 2. So here 2 by omega square t sin 2 sin square omega t by 2, right? A is equal to omega t. So s omega is equal to 2 into 2 4 by omega square t sin square omega t by 2. Thanks. We'll see you in the next video. Thanks.